Perception of the real. So here you have someone who is perceiving these objects, and they would be doing some qualitative and quantitative perception using words. So in their minds, they'll be qualitatively perceiving these objects by using the words, by using nouns and adjectives. So for example, they would use the word books, the color green, blue, white, yellow, lying down, standing up, new, smooth, group, etc. So this is qualitative reasoning. Then you have quantitative reason, quantitative perception. You'll be measuring and counting. So group would be singular, groups would be plural, a group of 3 books and another group of 6 books, 8 faces, 12 edges, heavy. Okay. Now, these words now that you are thinking can be written, and then you have quantitative writing using symbols. So these words are translated to symbols. So the word 3 here is a symbol for it. You can use B, the letter B for the word book. You can use the plus sign for the word and this is a sign for the equal sign. This is a sign for the number 9, N-I-N-E. And then you can translate B to X. Okay, so if you, anytime you see an equation like this, this means that words will translate it to symbols. So you have 3 books plus 6 books is equal to 9 books. Okay, 3x plus 6x is equal to 9x. All right, 8 faces plus 12 edges. All right, 8x plus 12y, for example. The letters have to be different because these are different quantities that's being represented. So therefore, every symbol you see in an equation represents a potential real-life variable. Okay, the entire equation says so to describe the relationship between them in the real-world phenomenon. Very commonly, you will see them as X and Y. So anytime you see X and Y, these are letters represents unknown of something that is a potential real-life entity. Here you have another situation of perceiving a moving vehicle, and quantitative mental thoughts will be happening. So you can be saying, no, remember, quantitative is like measuring and counting. So you can say, I saw a car moved a distance of 200 meters in 10 seconds from left to right. Therefore, the velocity of the car must be 200 meters in 10 seconds in the positive direction. So all these words now can be translated now to diagrams, to a graph. Okay, and here you have on the x-axis time, that the time that the car, you saw the car moving, and the distance travel on the y-axis. And then this line will show you the behavior of how the distance is changing with time. Okay, and then you can actually calculate the velocity by dividing the distance travel in the time taken. 200 meters divided by 10 will give you 20 meters every second, 20 meters per second. So here another situation with real translated to symbols, translated to diagrams. Okay, and this brings us a definition of the language of mathematics. First starts when we objectively perceive the real world with the 6 senses. Then in order to communicate the mental image that was formed in our minds, we design diagrams and graphs. We also convert words to symbols. In that way, we facilitate the documentation, thus written communication of ideas involving numerical analysis. Okay, so mathematics is basically the language that we use to communicate in a written form quantitative analysis. Okay, translating words to symbols and diagrams. So mathematics brings to the table this process. First, you have the real. You see objects, you hear song, you smell different odors, you taste different foods and so forth. You feel pressure on your skin, and you have intuition. So that is what is happening in real. Then the mind thinks using words according to your native language. Okay, if it's English or French or Spanish or German or Latin or Chinese, whatever your native language, if that's how you think using words. And you can think qualitatively using adjectives and nouns, colors, texture, aesthetics. And you can think quantitatively, measuring and counting, the height, the weight, compare values, the temperature. Now, these now are translated now, okay, because imagine the abstract. Socializing means you have to communicate. that requires spoken and written language. So this has to be translated, to be written. And you have qualitative writing using words, which are translated to quantitative writing, which translates words to mathematical symbols. Okay, so the word 3, here is the symbol for it. And there are many more examples. Okay, and that happens a lot in maths, translating words to symbols to facilitate written communication. So you can consider mathematics to be a language or quantitative communication. And this is reinforced by, for example, let's analyze the plus sign. Okay. The origin of the plus sign is credited to the 14th century French mathematician named Nicolas de Dorcem. When he was writing his math book, he found himself having to write the words et over and over. For example, try et quatuor égale 107, that's Latin. 3 et 4 égale 7, that's French. 3 and 4 is equal to 7, that's English. So he therefore then replaced the word et with the letter T, right? You can see T in et, you just take out the E, because he's tired of writing ET every time, so you just write the T, which then evolved to the symbol the plus, right? So that plus sign came from that word et, which is and in Latin and French. So words to speak et, and symbols to write plus sign. So you can see the translation of words to symbols happening, okay? Take note, in arithmetic, the word and is plus, always bear that in mind, okay? And here's a repetition of what we did earlier on. So let's move on to the equal sign now. The origin of the equal sign is credited to the 16th century mathematician named Robert Recorde. When he was writing his math book, he found himself having to write the words is equal to over and over. So once upon a time, these symbols were not there, and the mathematicians were actually using the words itself when they write in the books. For example, 3 et 4 égale 7. 3 et 4 égale 7. 3 and 4 is equal to 7. So he therefore replaced the word is equal to, because is equal to probably too cumbersome for him to write every time. You have to write is equal to over and over. He got tired of doing that, with 2 horizontal parallel lines of equal length. So the words to speak école ensemble, that's equal to, and translated to the symbols that we are familiar with, the equal sign. These symbols were designed in India via the rule of counting the number of acute right angles created. So a symbol has to be created for 0. The word 0 is a circle with no angles. A symbol created for 1. Here it is. And the technique that they used was a symbol with only 1 angle. For 2, 2 angles, there is a 2, 3, 4, 5 angles, 6, 7, 8, 9, etc. So these symbols that we use to represent the numerals of counting, these ones originated in India, and that's what we use today in our modern times. Most of them have been transformed, they become more curved and so forth, but that's where they originated from. The Romans had their different way of writing numbers. Their number 5 would be a V, for example. Okay, but these symbols for counting, for representing numerals, were originated in India by using the number of angles in the symbols. All right, so the whole counting, the whole trying to communicate quantitatively using symbols, and you can actually see it happening. Maths is a language. Okay, so here's a write-up of the summary of what we just talked about. The numerals, the origin of the equal sign is credited to Indian. And the numbers that we use, the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, here it is. Okay. And the equal sign was also a translation from the word is equal to 2 horizontal parallel lines of equal length.